Okay, so now we've gone over digital control signals. We've gone over analog control signals with our sliders, and how those um, operate our PWM low side switches. Now we're going to talk about our lighting capabilities and how we dim and brighten the lights inside the room. So just to show you an example of that, we're turning on these lights. Oops. Yeah, so the lights turned on in room 1, room 2. But I was wanting to see. Okay, great. So let's just observe that the lux just changed to 290. So we want to see how that works. So right now, I know we talked earlier about changing the PWM to 120 hertz, and that was set in this place here. In order to do that, we needed to also increase the control values for the servo position. So now the max and the min have doubled from what we had, because originally this was 150 and the max was 500. And what we're doing differently is that for our lights, they are controlled by the H bridge, and the H bridge has 2 PWM signals because the LEDs have only a power on and a power and a ground pin. Basically, we need to only submit about so if we want to submit 100 so if we want the lights to be fully on, we need one H bridge side to have connection to ground, and we need the PWM signal of the power to be fully on, which means we're sending completely 12 volts. So in order to do that, we need to make one PWM which is connected to the LED ground completely zero, so that it connects to ground. And also we need to connect our our upper PWM, which is connected to the power pin of the LED, and we need that to be fully on. So let's go a quick summary of what I just said. So let's look up okay. Let's look up a quick light here, and this is draw.io. If you're in a capstone team, it's a good source for presentations. You might think otherwise, or might hear of better options, and that's perfectly fine. This just works well. So let us show you what we mean. So in order for this to be on, we need to have a positive and a ground. So make that a bigger, and that as well. Okay, so we need a positive and a ground. So in our H bridge, or on our RJ12 port, we have 2 PWM signals connected to these 2 basically LED pins, if you will, but they're just 2 wires being connected. So that means that the negative wire needs to be connected to a ground, right? So this line, this PWM, needs to connect to the Lana board ground, and this power needs to have full PWM, or full 12 volts, in order this to be completely bright. Okay, so what we mean, let's actually move this. Let's move that over there. Okay, so what we mean is we're connecting a PWM here, which in this case is going to be the low one. So 10 is the low PWM, and if I go here to one of the lights, okay, so see how 11 is now the next PWM channel. So we have 10 and 11. So 10 is connected right here, and 11 is connected on the positive end of this light. So 10 needs to be 0, connecting it to ground. So what we're doing here is, this is kind of like a cheat code to make this channel completely 0. So what you do is you type in 0 and 4096, and this means that basically this is connected to ground, and in this situation this is connected to our power pin. So this needs to vary in duty cycle. So vary the duty cycle to dim the LEDs. Right? So if I send a 50% duty cycle on this PWM, then we expect to get half brightness. And that's how that operates. But let's just show you a little bit more about that, and let's actually stop this video and wait for another one.